Okay, so the next couple of questions are true or false questions. We have 6x times x, or sorry, x to the power 6 times x equals x to the power 7. So let's see if that's true or false. Let's start with the left side. We have x to the power 6 times x, right? What does that equal? Well, remember this x right here has a hidden invisible exponent of 1. So we don't want to forget that, right? There's a 1 there. And then all we have to do, since they have the same base, is add the exponents. So x power 6 times x power 1 is x to the power 6 plus 1, which is equal to x to the power 7. So the question, everything on the left here is equal to x to the power 7. Is x to the power 7 equal to x to the power 7? Is that true or false? You know, I think that it is a very true statement. So this is true, right? X to the power 7 is x to the power 7. That's what that has there. So very nice. Let's check the next one. Now, this one will probably confuse little people because there's fractions, right? But again, the same rules apply. So if I have x to the power 1/2 times x to the power 1/2 times x to the power 4, all I'm doing is adding the exponents, right? So 1/2 plus 1/2 plus 4. And you know, if you really don't like adding exponents or fractions, you could always use Desmos, like I mentioned. So 1 divided by 2 is 1/2 plus 1/2 plus 4 is equal to 5. So this is equal to x to the power 5. Now again, is x to the power 5 equal to x to the power 5 is what it's asking. Is that true? Of course it's true. Very true statement. What about this one where we have more variables? We have x to the power 3 times y times x to the power 4 times y to the power 5. So let's just write that out here. We have x to the power 3y times x to the power 4 y to the power 5. Well, we could kind of sort these, right? We could do x to the power 3 times x to the power 4 times y to the power 5. And now look, all the x's are together, so I could combine those, right? They have the same base. So 3 plus 4. And then I can combine the y's, right? 1 plus 5. And that's equal to 3 plus 4 is 7. And 1 plus 5 is 6. So the question is x to the power 7, y to the power 6, is that equal to x to the power 12, y to the power 5? No, that is different. Look, 7 and 12 are not the same. 6 and the 5 are not the same. So this is false. And I'm just going to write this over here where I have some room. Okay, one last one. 2c to the power 2 d to the 1/2 times 4c times d to the 1/2. Okay, so we have a little bit more in here. And again, I'm just going to kind of rewrite this. C to the power 2 d to the power 1/2 4c d to the 1/2. Now let's just combine the things that are combinable. So 2 times 4 times c squared times c times d to the 1/2 times d to the 1/2. Okay, so we can kind of put these in pieces, right? 2 times 4 is 8. Then we have c to the power 2 plus 1. And then we have d to the 1/2 plus 1/2, right? So there's each kind of individual piece of it. So we have 8, 2 plus 1 is 3, and then 1/2 plus 1/2. Again, I could go in Desmos, just do 1/2 plus 1/2. That's equal to 1. So that's just d. So is 8c to the power 3d equal to 8c to the power 3d? Is that true or false? Those both are the same, so that is true.